All right, let's jump right in. You know those stories about secret documents, hidden playbooks that have all the answers? Well, today we're actually cracking one open. This is what we're calling the Master Blueprint, and it's all about how to conquer one of the toughest math challenges out there for middle schoolers, the AMC-8. So, how do you do it? How do you conquer a 25-problem math gauntlet in just 40 minutes? I mean, really think about that. That's, what, like a minute and a half per problem? And it's not just about raw speed. No way. This is a test of strategy, of creativity, and yeah, mental stamina. So how do you even begin to prepare for something like that? It's definitely not about memorizing a textbook full of formulas. It's about having the right tools.
And that's exactly what this blueprint is all about. It's a collection of seriously powerful tools. I want you to think of it like we're in a digital vault, and together we're going to pull out the 4 most essential tools you're ever going to need. And these aren't just for solving problems. They're about learning to think like a true problem solver.
Okay, let's get to our first section. Our first tool, believe it or not, it comes straight from the world of high-stakes finance. Now, on paper, we're talking about algebra and ratios, but let's call it what it really is, the language of relativism. It's all about understanding how everything connects and, changes in relation to everything else. So, in the world of finance, and honestly in most of math, it turns out relationships pretty much just come in 2 main flavors. First, you've got direct variation. Super simple. The more stuff you buy, the more it costs. Easy enough, right? Then you've got its opposite, inverse variation. The more people you get to help paint a fence, the less time it takes. See? They're just 2 sides of the same coin. And knowing which kind of relationship you're looking at, well, that's step 1 to mastering the whole system.
And really, this is the core idea. It's all relative. It doesn't matter if we're talking about stock prices or currency exchange rates or even those classic word problems about 2 trains leaving a station. The point is, nothing exists in a vacuum. Ratios and proportions, those are the hidden levers controlling all these seemingly complex systems.
But here's the thing. The blueprint isn't just about giving you tools. It's also about warning you about the traps. And one of the biggest, most common ones out there is the percentage trap. It's designed to prey on your gut feeling. And let's be honest, our intuition with percentages can be seriously wrong. Let's see exactly how it works.
Okay, so picture this. You've got a stock worth $100. It has a great day, goes up 50%. Awesome. Now you've got $150, but the next day it drops 50%. Your brain immediately thinks, okay, I'm back to even, right? Nope, not even close. That 50% loss isn't based on your original $100, it's calculated on the new value, the $150. And half of $150 is $75. You're left with just $75. That's the trap. A 50% gain followed by a 50% loss doesn't cancel out. It actually leaves you with a 25% loss. This is a classic gotcha moment the blueprint helps you spot from a mile away.
All right, let's move on. For our next section, we're shifting gears completely. We're leaving the abstract world of finance and stepping into something you can literally see and touch, urban architecture. The tool we're going to look at here is geometry, which, when you think about it, is basically the source code for physical reality. And right at the heart of that code is this beautifully simple yet unbelievably powerful formula, the Pythagorean theorem. Come on, you've known this forever, right? A squared plus b squared equals c squared. But the real power isn't just memorizing the formula. It's learning how to see it everywhere around you.
I mean, just think about it for a second. Every single skyscraper, every bridge, any structure that reaches for the sky, it's all governed by this one principle. Those diagonal supports you see, the perfect right-angled corners, those aren't just random design choices. No, they're the fundamental constraints that literally define the skyline. And maybe the most famous, the most elegant example of this is the classic 3-4-5 right triangle. It's this perfect, clean relationship with whole numbers. It's so reliable that builders have been using it for centuries, just to make sure their corners are perfectly square. It's kind of like this little mathematical secret that's been hiding in plain sight the whole time.
And seriously, once you start looking for it, you just can't unsee it. You know when you buy a TV and it says it's a 50-inch screen? Well, that's the diagonal. That's the hypotenuse. Or the truss is holding up a huge bridge? That's just a whole network of right triangles. The Pythagorean theorem is pretty much the universal blueprint for building anything stable.
Okay, on to our third tool. So if geometry is the blueprint for the physical world, then number theory, well, that's the secret key to our digital world. Seriously, this is the math that's protecting your bank account, your passwords, your entire digital life. We're talking about the mathematics of cryptography.
And this idea, the remainder of a division, isn't just a leftover, it's a secret key. This gets to the absolute heart of modern encryption. The whole field is built on a concept you probably learned in what, 3rd grade? Remainders. In the fancy math world, we call it modular arithmetic, or sometimes clock math, because the numbers just wrap around, kind of like the hours on a clock. And that little leftover number, that's not junk, that's the secret key to the entire system.
So just how powerful is this idea? Let me throw a crazy problem at you. What is the very last digit of the number 3 to the power of 2025? I mean, 3 times 3 times 3, 2025 times. You could never ever calculate that by hand, and a calculator would just give up. But with the blueprint, you don't have to.
Because the secret here isn't about brute force calculation. It's about pattern recognition. Just look at the last digits of the powers of 3. Let's do it. 3 to the first power ends in 3. 3 squared is 9. 3 cubed is 27, so it ends in 7. 3 to the fourth is 81, so it ends in a 1. And then 3 to the fifth is 243. And look at that, it ends in a 3 again. We found a cycle.
The pattern, 3, 9, 7, 1, it just repeats over and over every 4 powers. So to solve for that massive exponent, 2025, all we need to know is where it lands in that 4-step dance. So we just divide 2025 by 4 and see what the remainder is. Turns out the remainder is 1. That means the last digit is going to be the first number in our cycle, which is 3. Done. No supercomputer needed. That is the power of number theory.
Okay, so we've unlocked tools for finance, architecture, and even cryptography. But this final section, this is maybe the most important part of the blueprint. And it isn't about a specific type of math at all. It's about your mindset. It's about how you approach the battle itself.
Because let's face it, in a high-pressure timed competition like the AMC 8, knowing every formula in the world won't save you if you can't manage the clock, if you crack under pressure, or if you don't think strategically. So what we're talking about now are the battlefield strategies for that 40-minute gauntlet.
So here's what it all boils down to. First up, pacing. You absolutely have to fly through those first 10 or 15 problems to bank some time. Next is triage. You got to get good at spotting those problems that are just total time sinks and have the discipline to skip them and come back later. Then there's pattern recognition. We just saw how powerful that is. And please, always do a sanity check. You know, if you calculate the speed of a car and get 5,000 miles per hour, maybe double check your work. And finally, don't forget to work backwards. It's a multiple choice test, so use that to your advantage. Sometimes just plugging in the answers is the fastest path to victory.
And that brings us to the end of the blueprint and to one last thought to leave you with. After looking at all these tools and strategies, you really have to ask yourself, is true genius about having a brain stuffed with memorized answers? Or is it about building a way of thinking that lets you figure out the answer to any question you might face?